G'day viewers, Alan here. Welcome to my workshop. And this is episode 5 of my Webster journey. I hope you're going to find some interesting stuff here. So an assortment of things actually. I've done the exhaust cam, valve blocks, and the valve guides. The spring's just sitting there for effect at the moment, and one of the valves. And and I've also done the a shoulder bolt for the rocker arm. So let's get started. So for the exhaust cam, I need to have a piece of material that's turned up to be 18.08, and I think we've pretty much got that there. I think you can perhaps see. And the drawing also, I've sort of a bit of a hybrid between metric and imperial, but I'm going for a 10mm here. So I've got my, that's a pretty good fit in there, my 10mm yes, my 10mm dowel. So that's all good. And I don't know how many times it's going to take me to get this, but I've turned up 50mm of stock at 18.08 dimension, although I've only actually bored it to 20mm deep or something. Anyway, the other thing is I've done it in the collet block, so I can just take it out of here, carry it over to the rotary table and drop it into an ER40 collet holder on the rotary table. That's an MT3, but at least they can share the collet and the nut. So let me do that, and I'll bring you back when I'm over at the table, over at the rotary table. Okay, so I brought my piece over from the lathe. This was a bit of just 19mm bar, and I just did a practice run on, and that seemed to work just fine. So hopefully we'll get it in one. Right. So I think we'll just leave that piece in its collet. Have to be ridiculously tight. There'll be that much force on it. These other bits out the way now. So I've written out a recipe for myself to follow here, because I don't trust myself not to miss a step out or otherwise stuff it up. But the key thing to recognise, this is from a CAD package, 2 images of the part, one rotated 31.25 degrees behind the other, and when we do that we see that the flat piece of the camshaft, the cam, becomes will line up with my y-axis, which should make life fairly easy. And the only real check that we've got is that when we finished, these points are 6.44 apart. Otherwise we just we've got the diameters and that's that. So it's probably not that much to it really, but there's still plenty of opportunity for me to mess it up, so let's see what happens. Call that 0. The piece has to be 4.7 thick, so I'll actually mill down to 5mm just to give myself a bit of clean up on the other side. But I'll go down in, I think 1mm deep passes should be fine. We'll give that a try anyway. That's got me to Y0, so we can lock Y now and unlock the table. And counterclockwise to 148 degrees. Lock the table at that, and then come straight out the front. Unlock Y, blow that off so we can inspect. Alright, well we've got a bit of raggedy stuff, but perhaps you can see that there is in fact an exhaust cam shape evolving. So I'll get rid of that hairy stuff. But I just realised one thing, what I meant to do and didn't do was use an offset of the required thing plus half the cutter and about 0.1 or 0.2, so I could come back afterwards at full depth and do a single pass all the way around. It's possibly not too late to do that, so even though I've done the first piece here, I will adjust my offset to allow for that. Anyway, you've seen how it's done. I'll bring you back when I've made a lot more progress. Okay, so we're at depth, almost at the diameter. This is my final clean-up pass. I'm only taking about, I don't know, barely 0.1 of a mil off. It's just a final clean-up. And a final opportunity to stuff it up, I guess. And for better or for worse, there it is. So that top witness line you can see there is going to get turned off. That was from when I started off at the full size instead of leaving myself a clean-up. But anyway, I've got enough material underneath that I can just chop that off. So I'm thinking this is a success at this stage. Okay, obviously back in the lathe, so I'm going to clean the face up and take the that millimetre off that was marginally undersized. I think that's enough. I've just got a burr there to clean off. I will finish that off by hand, I expect. But that looks alright. I will get the parting blade set up. That's making a bit of a meal out of that. Maybe I need a new tip. So I had a close look at the business end of the inset and I could see it was quite worn, so I put a new one in. I think the other one must have given most of its life to when I was parting off that 90mm or 100mm block for the flywheel. Anyway, be that as it may, I better just check my depth as well. I don't think this 4.7 is that critical anyway. I think that'll be alright. Yeah, that's better. That's actually cutting now. I reckon I can speed it up a bit now. Right, well, good clean up. Let's see what we've got. Okay, so I've just taken it out of the lathe and deburred it. Haven't polished it or anything yet, but it's looking like a cam. Actually, the finish off that end mill is pretty good. There's one thing I think you can see fairly clearly. The transition from the nose of the cam onto the flanks is quite sharp. The cutting tool did an excellent job, but I have to wonder whether I should soften those hard transitions with a bit of rounding. I'll have to think about that. But otherwise, this piece is done. And when I cleaned it up, it was even the correct fit on the 10mm dowel, as you can see. It was just a couple of burrs in the way. Anyway, so very happy with that. I made enough material that I could make several of them if I needed to, but I got lucky and got it in the first go. Okay, so now I've finished the exhaust cam. Switched back over to other parts of the valve train and the rocker arm. So you saw in the previous video making that. And I just noticed I've still got to drill the hole there for oiling it. Anyway, so I made up a shoulder screw to mount it, and I made the screw with a M3 thread into the side frame, and then there's a plain shank which I made at 1/8 of an inch or 3.18, so that I could use a 1/8 inch reamer to open this hole out. And the reason I did all that was so that the unthreaded shank, the plain shank, would butt firmly against the side frame. That's the whole point of a shoulder bolt. So you can do the bolt up firmly, but the pieces that are but it won't trap the pieces that are under the head. So I made up a spacer, of course, to go in there, and after a bit of experimentation I've got it so that the this screw is representing the tappet will come up underneath this screw, which is representing the end of the valve stem, the top of the tip of the valve stem. This is just a bit of scrap to put that positioning piece there. Anyway, so now I'm satisfied that I've got the rocker arm in the correct place. I'll get rid of this thing and make up the correct valve block and the other pieces that go with it. Right, so I had to take that screw out to get the rocker arm off and drill that tiny little hole for oiling. And while I had it out, I thought I might include a close-up shot of it. So that washer there is just a spacer that slides over the plane shank, which is 3.18 or 1/8 of an inch. This washer here is is about 3 millimeters, just a hair under actually, and it won't go past the start of the plane shank. So when it goes into its threaded hole in the side plate, the screws fetches up against that washer. So when I do a final assembly, I'll put Loctite on the thread. It shouldn't get back past this washer, and so I should get a pretty solid setup. Well, that's the plan anyway. So I'm working on the bits of aluminium which will house the intake and exhaust valves. It's a 3-layer assembly. The middle block's called the valve block, and it has 4 holes in it, which is common to all 3 layers. And it will also have a pair of holes going through left to right as you're looking at it, which will secure this sandwich, 3-layer sandwich, to the side of the cylinder head frame. Now the drawing calls out for some weird 17/53 or something. Weird for me, I shouldn't poke fun. Anyway, I have 3mm screws, so that's what I'm going to use. Carefully positioning the holes, they're just inside the envelope, shall we say. So, and then there's a big hole through the middle which becomes sort of like the shared intake and exhaust port. Okay, so I won't drill the cross holes at this point because I'll use the setup that I've currently got for drilling the hole pattern in the other, drilling that 4-hole pattern into the other 2 pieces. So I'm doing the inlet and the exhaust valve blocks now, and they both have in common that the centre hole is 5/16 diameter, and it needs to be counterbored 3/8 diameter for a depth of 0.031 thou, 31 thou. And then this one gets 4 holes in it in the corners, same as the one I've just done. And I'll tap these for M3, and this one will just get 4 through holes. Okay, speed somewhere near it. So we want to come down. Oh, I'm all set up for metric here. So what's 31 thou? I'll just do that out. Okay, well, I've just changed the DRO to read in thousandths, so it's easier. So 31 thousandths of counterbore. Right, if the DRO isn't lying, that's 31 thousandths of counterbore. Okay, well, everything else is just drilling holes and tapping, so I'll bring you back when I've done all that. Well, that seemed to work out pretty well. Got all my screws in. Things seem to line up fairly well. The screws operate just fine. So it's all good. Obviously I've got to cut the screws to length. So next step is to mount it back in the vise and do the cross drilling for the inlet and exhaust ports and the 2 screws that mount this to the cylinder head block. So better get on with that. Okay, well, I must have been taking my stupid pills just now because, as the observant amongst you might have noticed, I assembled these pieces in the wrong order. Still, it's a testament to the alignment of it all that all the screws still work nicely, no matter which way round I assemble it. Part of the key for why the pieces fit so nicely though is I actually drilled the holes. These are 3mm screws, but I drilled the holes with and I measured the unthreaded shank diameter to be 2.95, I beg your pardon. So rather than drill using a 3mm drill, which would go oversize anyway, I decided to use a number 33 drill. Number 33 is nominally 2.87mm, but obviously that drill is slightly oversized as well. So these screws are really quite a close fit in their holes. So obviously I have to put the holes in exactly the right place, but with that done you get this very good alignment. I haven't touched the outside. You can see when the light gets on it there, it's not perfect, but it's pretty damn close, and I don't think any further outside treatment is going to be needed. Anyway, time to drill the two cross holes for mounting it to the cylinder head block, and the holes in the ends for the ports, the valve ports. So when I'm drilling these very small holes with a thin drill which can wander, I choose to start them using a centre drill just to get the point of the drill in the right place. You will have noticed I don't do much in the way of marking out. I rely on the DRO, and not everybody does it that way, but it seems to work that way for me. The only thing is, in the absence of marking out, in some ways it's probably easier to make a mistake, but such is life. And I've got the speed set for 2000 RPM. That's the other thing with these small drills. It would go, high speed helps. So I've switched to the number 33 drill, and now we'll find out whether it's going to miss the oversized holes I drilled for the M3 screws. Right, and we'll just do a test fit with a screw. Like I say, I depend on the drill actually going slightly oversized. So you can see what I mean about a number 33 drill giving a good close fit hole for a 3mm screw. So provided the hole's in the right place, you get good alignment. So hopefully the screw will be happy in this hole as well. Yep, perfect. So this is the setup I'm using for drilling the port holes. As you can see, there's not an awful lot of room here. I think it's a 7/32 hole into a quarter of an inch, or 8/32. So you really have got very little margin for error. That hole has to be right on centre, because you've got about 0.4 each side. So what I've done is use a stiff drill as a pilot. Oh, and the other thing is the depth. It calls out on the drawing for a depth of 4.76mm or 0.188, and that's from the drill point. So you finish up with a hole with parallel sides that are less than that depth. That's by design. Anyway, so I'm going to take this drill down to about 4.4mm, and then it'll be the guide pilot for this guy to make sure he stays on centre. And that's it. And as you can see, there's very little room for being off centre. So making a valve guide here, start off with some pretty simple turning. We just got a couple of diameters there and a taper, 2.5 degree taper. Then I'll be parting it off and turning it around in the chuck and boring it out for the internal features. Put it back in the chuck the other way around, clean it up and bore the holes. So I'm going to do the internal features of this valve guide now, which basically means drilling, what is this, a 732s I think it is. Yes, a 732 hole to about 3/16 depth, and then a 3/32 hole I think it is, some tiny bloody thing anyway, out to the back, and then reaming that to that size. Now I didn't think I had a reamer that size, but courtesy of my dear old dad, long departed sadly, I do in fact have a reamer the right size. This is possibly a legacy of his very early working career. He was an Air Force mechanic in the Second World War, worked on Spitfires and such, and after the war he was carrying on that sort of trade for a little while and accumulated a few tools. Anyway, I suppose that's all by the by, but some of the things that I still have of his, like this, date from the 1950s, so I guess if they haven't paid for themselves by now, they're not going to. Anyway, to get the 732's hole started in the right place, we'll give it a dab with the centre drill, just to encourage it to do what we want it to do. Now this is pretty small diameter in the brass, so I think we'll go for 1300 RPM here, so it might be earbuds time. Well, for me. Now we don't want the feed on. Right, off we go. Okay, that should be enough to get my drill started in the right place. Okay, so what the drawing calls for is to go in 4.76 deep from the point where the flutes just start cutting at full diameter. I think I'm there. Yeah, I reckon I'm there now. Close enough anyway, so we're going to call that 0. And go in 4.8. No, that should be it. Well, that's going to be it, for better or for worse. So I'm going to get the small drill in. So I've never used this 3/32 reamer before, and I didn't even know I had it, to be honest, but anyway, I'm going to make the hole 5 thousandths undersized, so we're using a number 43 drill, and hopefully the reamer can sort that out. Well, here we go. Get the speed up for the drill anyway, and hope it comes out in the middle at the back. It's pretty hard drilling gently on a machine this size with such a small drill. Just the weight of the hand grip on the tailstock handle was trying to turn the the drill in faster than I wanted it to go. Perhaps I should have been doing this on the Hercus. But I got so used to the DRO, I don't like using a machine that doesn't have the DRO now. Mostly because my eyesight's not that great, and trying to read the little dials on the Hercus is not that easy for me. Anyway, by the by. So we certainly won't be wanting 1300 RPM for this. In fact, I think I'm going to find a way of doing it with by hand, so I've got some feel. So I'll bring you back when I've got something sorted out for that. Okay, so I think we're set up here. Give that a good squirt of lubricant, and the setup should allow for gentle pressure here. I'll just rotate by hand. We're nearly there now, actually. It's quite tight actually in the hole. Tighter than I thought it would be. Maybe a 5 thou wasn't enough allowance. Oh, there we are. Sure I don't stab myself on that point. Yeah, right out of the way. It's pretty tight. I think I'll check that diameter, hole diameter, with a couple of gauge pins. So 332s is 0938. So 093 should go, which it does. A little bit of movement, but 094 shouldn't go, which it doesn't. So I reckon we're pretty much on size, which means Dad's 70-year-old reamer came up trumps. Good one, Dad. So the last operation on this valve guide is to cut a valve seat at 45 degrees. Now I can't be bothered getting out the sine bar, so I'm going to do it like this, which is a little bit crude, but hopefully I'll get away with it. Now, here's another eyesight challenge. The seat is supposed to be 0.4 of a millimetre wide. Yeah, I think that's basically going to translate to I can just about see it. I don't know whether you can see that, but we just started to get a witness line. Well, I don't know how the hell I could measure that. I'm trying to hold the half millimetre beside it for comparison. It doesn't look quite as big as a half millimetre, so I guess that's going to make it 0.4. I don't know whether it's better to go slightly large or keep it undersized. But I suppose if necessary I can find a way to enlarge it. Anyway, I'm calling that it for now. So that basically completes the operations on this thing, and let's see if it fits in its aluminium block. Okay, so perhaps you can have a clearer look now. So there's the valve guide. That flange has to match into that rebate, and I tried to show on the lathe that that's actually a pretty good fit in there, but will press in without any trouble. Going the other way around, that larger diameter boss there has to engage in the body of the valve block, and with final assembly we'll use some Loctite, but I think you can see that that's actually a pretty good fit in there, and that's going to take a bit of a push to drive that all the way home. And then Loctite will make sure it gets the message to stay where it's put. I'm hoping that the thickness of that flange will pretty much match the rest of the shove that's going to happen there, so that when you look at this from the outside, this is the outside face, that brass face should come up flush with the aluminium, or somewhere near it, hopefully. I'm quite pleased with the exit of the hole for the valve stem, so just make another one now. Alright, well I think that turned out alright. I finished up flush on this face, which they need to be, and pretty close to flush on the other face, so I'm pretty happy with that. I think it's all going to go together without any trouble. So I guess it's time to have a think about making some valves. Trying to make a valve here. It looks like I'm trying to make a needle, but this will, I think, might be my final cut. I need 2.36, but I'm aiming to get 2.4 with the lathe, and get the rest with emery and wishful thinking. Well, we'll see. This is not really what a lathe this size is meant for, I don't think. We were aiming for 2.4. It's not a bad surface finish, all things considered. So what did we actually get? .39. Okay. I don't know whether I dare take another cut actually. I'll think about that. A valve. Well, a wannabe valve. I think it's another piece of jewellery actually. And so I have my first valve. It's not quite finished. I've got to drill it. I've got to bring the stem to length and do a cross draw hole. But I was quite pleased with the way that turned out for a first effort. Yeah. So I'm starting to feel like I can actually finish this project if I keep making progress like this. Okay, well, hopefully you'll agree that I've made some worthwhile progress since the last video. The progress point at the moment is a little bit sawn off with like one valve done and in fact not even complete, and the reason for that is that my plans have just suddenly changed, and I've got something else I have to be focusing on for the next week or so. Anyway, I hope you enjoyed this video, and I look forward to seeing you when I get back into the workshop and do some more of this project. Cheers.